By the time you're in Algebra 2, you've probably gotten very comfortable adding, subtracting, and even multiplying polynomials. 3/4 are the orders of operations. Now it's time to learn how to divide polynomials by each other. And the process of doing that is actually quite different to everything else. It's not so intuitive, but I'll walk you through the process. Well, really, by this time you've already done such things as, simplifying polynomials. If you had, a function like 2x plus 4, we can simplify that. We can factor it. That is the same thing as dividing it by 2. That's how we know this is 2x plus 2. This process right here. But this whole thing, it can also be rewritten in the same way, we long divide integers by each other. This is the same thing as, we put our divisor outside the house, or whatever they call it these days, 2x plus 4. Now, how many times does 2 fit into 2x? Well, it fits into an x times, multiply through, 2x, cancel 4. How many times does 2 fit into 4? 2. Whoop. Yeah. So that process, we're going to be using this right here, long division, in order to divide polynomials through not a very fancy name, but polynomial long division. And in the same way that multiplication is the inverse of division, division is the inverse of multiplication, it's the same thing that, let me just show you. If we had something like x plus 4, x plus 6, dividing this out, you get x squared plus 10x plus 24. Now we know that these two are factors of each other. So if we were to divide this by x plus 6, that's the same thing as taking x plus 6 out. So if we were to divide this by this, we would get this. So let's set up our long division and let's walk through how to do this. So let's make this our divisor right here. Let's set up x plus 6 as our divisor. And inside the house, we have to put this whole polynomial inside. So x squared plus 10x plus 24. I'm already getting pretty far off screen. So in the same way we ask how many times does this go into that? But instead of considering our whole binomial here, we just consider the x term. We ask how many times does x fit into x squared? Well, it fits into it x times, because x times x is x squared. So, and we write our new thing right here on top of the corresponding degree. We wouldn't put it right here because then that would be on top of our squared term. We put just the single x right here because that's on top of our linear term. Now, in the same way we do regular long division, we then multiply this term by this term right here. So let's multiply it through. We get x squared plus 6x. And then we have to subtract this term from that. The same way we would regular long division. But this isn't just subtracting the x squared. We are subtracting the whole term. So we distribute. The x squareds cancel, and then this just becomes negative 6x. And then keep going. 10 minus 6, we're going to get 4x. But then let's ask, how many times does this, remember just the x term, fit into 4x? Well, it fits into it 4 times. And then we multiply through again. Now, we know they're always going to cancel, because if you do this correctly, our x terms are always going to cancel. So I'm just going to skip that step. I'm just going to cross this out right here and just multiply the 4 by our 6. Which is just 24. The x's cancel, and then we're just left over with our 24. And then we subtract through and we get a remainder of 0. And this 0 as our remainder tells us that this is a factor of that. Do you see? Very, very pretty. So when you get a remainder of 0, that is how you know that your solution, your quotient, is a root or a factor of this. But this, I mean, quadratics, by this time you should be able to do those like in your sleep. And while, yes, it is useful, especially when, you can't like know off the top of your head what like one of the roots are, polynomial long division is most useful when you have extraordinarily large polynomials. I'm gonna grab my notebook here because I wrote a very big one, and then we're gonna factor it. It was, this good? Yeah, that's good. X to the 5th power minus 9x to the 4th minus 5x cubed plus 105x squared plus 4x minus 96. Can you even see that? Ah, yeah, it's very small. There we go. 4x plus 4x minus 96. Okay. Now, if I asked you to solve that, like normally without long division, you'd be like, dude, what? Where do you even begin with this? But now that we know long division, we can do this sort of intuitively. All we have to do is find a root. If we find one root, then we can simplify it down further. Then we find the roots of that polynomial. We can, keep going. Now, I made this specifically. Their quintic equations are actually quite difficult to solve. I made this one so that we could go through it together. So, our y-intercept is the product of all of our roots. Say if we have, a polynomial that's made up of like just linear terms like this, like x plus b, x plus c, and then x plus a. When you multiply these all out, our y-intercept is going to be the products of just our constants. Our y-intercept for this polynomial right here would just be a, b, c. So if we factor 96, the factors of 96 would be the roots of this. Now remember, this doesn't work for all quintics. I made this with the intention of solving it in a very simple way, just to showcase how polynomial long division can be used to simplify something like this. So, firstly, this is a negative 96. So, let's try to take out just a negative 1. So if negative 1 was used as a factor of this, then that means we're going to divide this very long by x minus 1. Can you guys see that? Yeah, okay. And now we're gonna do it. Hopefully I don't mess up at any point. We're gonna deal with some big numbers here. Okay, so how many times does x fit into x to the 5th power? That fits into an x to the 4th times. Multiply it out. This one will always cancel, and then we get negative x to the 4th. Now remember, we're going to subtract by this whole term right here. So this turns into a positive. So minus 9 plus 1, that's going to be minus 8 x to the 4th. Now let's bring our next term down, 5x cubed. How many times does x fit into negative x to the 4th? That fits into it, negative 8x cubed times. Multiply it out again. This will cancel with that. You see, we would get a negative 8x to the 4th, but because we're going to be subtracting it, that would make it positive. That's why we can just cancel it out like that. And then negative 8x cubed times negative 1, that's just going to be positive 8x cubed. But then we're going to subtract the whole thing. So we're going to make this negative. Oh, I had like a brain fart there. Subtract down, we get negative 13x cubed. Now x fits into negative 13x cubed, negative 13x squared times multiply it out. This one, I'm just going to bring our next one down, 105x squared. That cancels. We would get positive 13x squared. Yeah, positive. And then we would subtract. So 105 minus 13. You're dumb. Oh, 92. Ay, ay, ay. It's not my good day. Of course it's 92. What am I, crazy? 92x squared. Okay, how many times does x fit into 92x squared? We're getting very close to the end now, and you see we're gonna run out of space here real quick. Let's wrap it up. That fits into it. 92x times 92x times. Multiply it through. 4x. Oh my god, I'm losing my mind here. That fits into that. Negative 92. 92x. Subtract the whole thing. So this is adding. This is going to be 96x. How many times does x fit into 96x? 96 times. And now we can solve this through, right? We would get negative 96 right here. This would cancel, and then we would get a negative 96, but then we would be subtracting it. So that will make it positive, giving us a remainder of 0. Meaning that x minus 1 is a factor of this very large quintic polynomial. And now that we have simplified it, we know that our new polynomial is x to the 4th minus 8x cubed minus 13x squared plus 92x plus 96. Whew. Now, as you can see, we took a negative 1 out of the negative 96. That's why our y-intercept is still 96. We only took a negative 1 out of it. We just changed it from negative to positive. Cool. Now, all right, so here is our new polynomial without any of the extra work done. So, yeah, this is what we solved when we factored out the x minus 1. Now, that isn't just to say that the x minus 1 is done for. It's not gone. If this was a function and we were, just trying to factor it out, make it easier to look at, then we would say that it's this term times what we divided by. Because when we multiply this back into all this, then we get our original quintic equation. Now, this isn't to say, I must reiterate again that solving quintic polynomials are very difficult at times. And I created, this polynomial just as a way to set it as an example to use long division. Go to say that again. So, like we did last time, let's find some more roots of 96. So let's think here. Off the top of my head, 96 is 4 times 24. So, let's take a 4 out of this. But maybe not just any 4. Recall, we also have some negative terms right here. So there's still a negative factor of this. So perhaps we can take out a negative 4, and then we will work with that. So the linear term we're going to be factoring by is going to be x minus 4. Cool. Just want to check that everything is right there. Okay. And now we can divide like we normally do. So x fits into x to the 4th, x cubed times. Multiply it out. These will always cancel, and we get minus 4 x cubed. Now recall, we're going to subtract this term right here. So these cancel, making this positive. So then we get minus 4 x cubed. Let's bring our next term down, 13x squared. And now we ask, how many times does x fit into minus 4x cubed? It fits into it minus 4x squared times. Now when we divide it out, we would get minus 4x cubed times positive 16x squared. Now we would subtract it out, which would make this cancel with this, and make this just negative. So then we are left with negative 29x squared. Let's bring our next term down, plus 92x. How many times does x fit into minus 29x squared? Well, minus 29x times, yeah. Multiply it out, always cancels. 4 times 29, 116? Yeah, 116, positive 116x. Now we are going to subtract by the whole term. So this changes into a subtraction. Now this, 92, I can't do that. Oh yes, very nice. Subtract through, we will get minus 24x. Do you see this? Do you see? Are you picking up what I'm putting down? So how many times does x fit into minus 24? X. Yeah, minus 24 times. Yeah, we already know 4 divided by 96 is gonna be that 24. We already know that this is gonna end up good. But just to show, we're gonna multiply it through. We get minus 24x plus 24 times 4, 96. And then we're going to subtract that term through, change our signs, cancel, cancel, left with a very nice remainder of 0. Showing that x to the 4th minus x cubed minus 13x squared plus 92x plus 96, when divided by x minus 4, our quotient is x cubed minus 4x squared minus 29x minus 24 with a remainder of 0, which tells us that x minus 4 is a factor, a root of this polynomial right there. Voila. All right. Now moving on from our long polynomial from before, I'm bringing a type of question you would normally see on homework in Algebra 2. You see, they would give you a graph, the function, and then tell you to factor it. What they expect you to do is to look on the graph, find one of the roots, and then divide that root from this. So, let's see. These two, they're not on definite points. We don't know if this is 1/2. We cannot say for sure if it is. So we can't look at these. Let's look at this one right here. Now we see 1, 2, 3, 4, 5. It crosses the x-axis at 5. So we can make an assumption that one of our roots is at 5. So what we can do is that we can divide this by that root. Now, what is that root? That root is x minus 5. Remember, minus subtraction is how we move further down the number line, and then plus is how we move further back. I know it's kind of weird to think about because we usually think of plus as up, but yeah. Okay, so let's work through it. How many times does x fit into 6x cubed? 6x squared times? Multiply it out, we get negative 30x squared. We're going to subtract this whole quantity, making this positive, giving us just x squared. X fits into x squared times, just x times. Bring our next term down. This will always cancel with that. When we multiply it out, we get negative 5x. Now we're going to subtract the whole term. This cancels, and that turns positive, giving us negative 2x. So, how many times does x fit into negative 2x? It fits into it negative 2 times. Cool. Bring our next term down, multiply it out. We will get minus 2x plus 10. Negatives cancel. Subtract the whole thing, cancel, always cancel, making this negative, giving us a very nice remainder of 0. So now we know x minus 5 is a factor of this cubic function, and the new term, the quadratic term, is 6x squared plus x minus 2. Yeah. Now that we know our other term, I'm going to erase this work here. Just this work. So that we can try and factor what we found, our quotient. So I'm going to write this down right here. 6x squared plus x minus 2 is a very nice quadratic function. So let's see. Rainbow method, since our leading coefficient is not 1, so multiply 6 by negative 2. So I'm just going to draw my little cross here. What multiplies to negative 2 and adds, or negative 12 I mean, my bad, and adds to 1. Negative 12 does not have that many factors. So when you saw that, you should have thought 4 and 3, period. Now how can we change 4 and 3 around to end up being 1? We could do 4 minus 3 is equal to 1. So we can know we get 4 and minus 3. 4 minus 3 is 1. 4 times minus 3 is minus 12. Now we can't just factor skipping all the work because we have a leading coefficient here. So let's expand this real quick. We get 6x squared plus 4x minus 3x minus 2. Now here, we can bring a 2x out of this, leaving us with 3x plus 2. Now I'm going to rewrite this down here. Now we have to ask, what can we take out of this space right here to make this right here? Well, that's just going to be a negative 1. We have the 3x and the 2, but there's minuses right next to them. So just take out a minus 1. Now we have solved our whole equation. Because here, our quadratic terms, or from our quadratic function, we took out 3x plus 2 times 2x minus 1. So we can say with confidence that our other root is at 1/2, and our other root is at minus 2 over 3. So let's write down 1/2 minus 2 over 3. So completely factored out, our full function, now simplified, reads as 3x plus 2 times 2x minus 1 times x minus 5. Now, this whole process is very long. And if you make even one small mistake, it screws up the whole thing. If only there was a faster easier way to divide polynomials? Well, there is. But this video is too long. Different video. Have fun.